Hey everyone, welcome back to Game Code Mastery. Today, we are continuing our flexible action system in C++ that you can reuse across any project. By the end of this action system tutorial series, you'll have a fully working action system in C++ that you can reuse across any project. This system will handle all actions such as jumping, dodging, and attacking. This system will also manage when different actions should block each other, when they can combo, and how they interact with and manage your character's state. In the last video, we implemented our action system component and got the core functionality working. In this video, we're going to implement the action interface, which will give us a sweet spot between modularity and maintainability. We are also going to improve the jump action, make our action system more flexible, and reduce coupling. To achieve our goals, we'll dive into some key programming concepts like inheritance, polymorphism, interfaces, and coupling, and see how they all come together in our flexible action system. Okay, with that out of the way, let's go ahead and get started. In the last video, we created an example jump action. Since it was just an example to test the action system, we didn't fully implement it. Let's fully implement our jump action by creating a jump action class. In the editor, let's create a new class that inherits from ACS action. So here in public action system, let's create a new class. Here in all classes, let's search for ACS action. Next, and we will put this in public action system actions. Including base class underscore in the name of a child class is a common naming convention in Unreal Engine. So let's follow that convention for our actions by naming our action ACS action underscore jump. And let's create class. You might be wondering why we created our jump action as its own class that inherits from ACS action. To understand that, you must first understand inheritance. Inheritance allows a class to acquire properties and behaviors from another class, creating a parent-child relationship. Our ACS action jump will inherit all the core functionality from ACS action automatically. Think of it as building on top of existing code. You get everything the parent has, plus your own additions. The key benefit is that the jump action inherits all the base action features, so there is no need to rewrite the base action logic. We just need to add jump-specific behavior onto our jump action. We've actually already been taking advantage of this feature in Unreal Engine. The action class inherits from a data asset, while our action component inherits from an actor component. Now that we've taken advantage of inheritance by creating our jump action, let's take advantage of another object-oriented concept known as polymorphism. But to do that, you must first understand what polymorphism is. Polymorphism means many forms, so one class, multiple implementations. Perfect for treating different object types uniformly while preserving their unique behaviors. This allows objects of different classes to be treated as the same type, while each executes their own specific behavior. In our case, inheritance allows each action to inherit the ability to start and stop, while polymorphism allows each type of action to produce different results depending on the action type. The benefit of this is that the action system only needs to use a base action class pointer to point to any derived action class object, and when it calls virtual functions, it automatically calls to correct derived class implementation at runtime. So start action on a jump makes the character jump, while on a dash, it makes the character dash. This works because in our ACS action class, our start action is a virtual function. Without virtual, calling start action through an ACS action pointer would always use the base version. The virtual keyword tells C++, check the actual object type at runtime and call that implementation, enabling the many forms to work. All we need to do to take advantage of this is to override the virtual function start action. That is why we marked this function as well as these other functions as virtual. Let's go ahead and override start action. Here in our jump, we'll just copy and paste that, and then add override here. And after that, let's create a definition. Let's start by just logging to the screen to help us see polymorphism and inheritance in action. So here we can do UE_log, log temp, warning, text macro, and here in quotes, let's add ACS action underscore jump, scope resolution operator, start action. Okay, and now let's copy this and go to the base action class, go to the CPP file. You can do so by in Visual Studio, holding Control and pressing KO. Here in Start Action, paste it and remove the underscore jump. Save all and go back into the editor. And let's try using live coding this time. Okay, now in order for this to work, we are going to need to find our jump action and change it to inherit from the jump action data asset, which is easy to do. Here in our actions, jump action, we just need to right click on it, convert to different data asset type. We need to convert it to ACS action jump. Okay, save all, open it up, make sure everything is still set correctly. And also let's go into the character class and let's remove all of this because we are going to be re-implementing that anyway. We can temporarily unplug this while we're testing, so that way this doesn't become a problem. And before we test, let's clear all log messages. And now let's try to jump. And as you can see, it's logging ACS action jump start action. It only outputs the jump actions version to the output log, but we don't lose the parent functionality by doing this. We can still call the parent version of the start action function. So while keeping the editor open, let's go to the jump action function and call super on it. Calling super like this: super scope resolution operator start action, passing in action comp. What super will do is call the parent version of this function. In our case, when calling the jump action, we'll call the parent version of the start action function first, and then our jump action specific logic beneath it. So here in the editor, let's start live coding. Let's test again, and keep in mind that if this doesn't work for you, then you can always close the editor and compile and build from your IDE. As you can see, the parent ACS action and child ACS action jump are both being called because both are being logged to the output log. This is inheritance and polymorphism in action. If we were to, for example, comment this out and comment this out as well, so for some reason it's not working correctly for me when I live code, I'm just going to have to build from the editor. Live coding can be hit or miss sometimes. And as you can see, nothing prints. But if I add the super back and only the super, then I try to jump, it only prints the parent version. Now that we've seen those concepts in action, we can remove those UE logs. Let's go ahead and remove them now. Next, let's implement our jump actions version of the start action function so that we can actually implement the jump action. So remember to close the editor. First, let's call super because we might need it later. Okay, next, let's try to play the action montage, but only if it is valid. Action montage.is montage valid. And we also need to check and action comp. Okay, now action comp, arrow operator, play action montage, action montage. We need to add the include so that we can use the action component. So hash include action system ACS action component.h. Okay, now we need to, from our action montage, access the actual action montage. And then you can see the inputs we have here. Next is the play rate, action montage, play rate. And next is a start section. So action montage, get montage section name. And we need to pass in an index. Let's just put 0 for that. And that's all we need to do. Okay, so what we can do here actually is, let's wrap this in an if statement, action comp, and remove that here. Okay, next, if a character, pointer, avatar character equals, let's cast to a character. And inside these parentheses, let's, from the action Let's get the avatar actor. Now, since we are using the a character, we need to add an include for that. So here at the top, let's add hash include a framework slash character.h. Okay, and now let's get the avatar character arrow operator. Let's call jump. Okay, now let's do something similar with stop action. So let's go to the action class and let's copy this one. Let's override it here in our jump action class. Create definition. Okay, and copy this. Remove play montage. And instead of jump, let's do stop jumping. Okay, and I'm noticing a mistake that we made here that we need to fix before we compile. And as you can see, we're checking if a montage is valid and only doing this if the montage is valid. Let's remove this. So that way we only play the montage if the montage is valid. And if it's not valid, we continue and jump like normal anyway. Let's also fix the stop action function. So we check if the montage is valid here. We actually don't need to do that. Now that should be all we need to do. Make sure your code is correct and the editor is closed. Now let's compile and run the editor. Okay, mine compiled successfully. Okay, now let's test in the game. And as you can see, jump is working. Next, let's work on the action interfaces. There are many ways we can implement our action interface. For this action system, we are going to use a grouped approach. More specifically, we are going to group related actions into multiple interfaces. The iCombat actions interface will have functions for things like attack, block, parry, and more. While the iMovement actions interface will have actions such as dodge, dash, and more. That will also allow us to later add other grouped actions such as iInventory actions. This grouped approach will give us a sweet spot between modularity and maintainability. Okay, with that out of the way, let's go ahead and get started. Let's go ahead and create it. So here in actions, let's create a new C++ class. And here under common classes, we should find Unreal Interface. If you don't know what an interface is, an interface allows multiple dissimilar classes to implement a common set of functions. This is useful when classes need shared functionality, but have no common parent other than the base UObject. In this case, an Unreal interface can enforce multiple objects to implement the necessary functions. You can think of it as a skill certification. Any object can be damageable or interactable without needing to inherit from the same parent. Interfaces can also help reduce coupling because you can call interface functions instead of needing to cast to some specific class. That's going to be the primary benefit for our action system. So with Unreal Interface selected, select next. Let's name this ACS Movement Actions. And let's create the class. Okay, now that you have created the Movement Actions interface, go ahead and close the editor. Now let's define the jump functions in our movement actions interface. Since the default character class has its own jump functions, we need to make sure there are no naming conflicts. Let's call the first one start jump action. Void start jump action. And the next one will be void stop jump action. Now, in order to make this more flexible, let's allow C++ base implementation plus blueprint override. And to do that, we need to make these into blueprint native events. So let's add U function. We need to make this a blueprint native event. And let's make this blueprint callable. Category will be actions. Let's do the same thing for this one. Now let's implement the interface in the character class. If you don't have a C++ character class, you can simply create one, similar to how we created all of our other C++ classes, except this time just select character. I already have a C++ character class. Go to ACS hero character. This has some basic default functionality just for camera and movement input. So this is similar to the C++ default third-person template. You can just create one of those if you want to get a reference to what I have here. But now let's implement the interface. But you might be wondering, how do you implement an interface in C++? Well, C++ supports multiple inheritance, which means a class can inherit from multiple classes. Unreal Engine only supports multiple inheritance through interfaces. So that's how we can implement the interface in C++, simply by taking advantage of multiple inheritance and inheriting from the interface. Public IACS movement actions. And we are going to need to include it before it works. Hash include system actions, and this should be ACS movement actions.h. Okay, and that has that fixed. Okay, now we need to implement the interface functions. So let's go back to our movement actions interface and copy both of these. Here under the public, let's paste them, but remove this. And for blueprint native events, we actually need to add an underscore implementation to these. I'll go ahead and copy that and add it to the one below it as well. And now we need to do override, because we need to override those functions. The underscore implementation version is the core C++ version of our function and gets automatically generated for us when we declare a function as a blueprint native event. Okay, now let's create definitions for these. Now we can do, let's do a unilog first. Ulog, log temp, warning, text macro, start, jump. And let's do the same thing. Stop jump. Okay, so now let's go back to our jump action here. After that, let's update our jump action to call our interface functions. Since we are allowing blueprint use of this interface, we need to call our interface functions in specific ways. Okay, so let's delete this old code here and let's create an actor pointer and let's call it avatar actor and have that be equal to action comp get avatar actor. We can wrap that in an if. And in here, we can check if avatar actor arrow operator implements arrows, parentheses, implements ACS movement actions. We need to include it here. So hash include action system / actions / ACS movement actions. Okay, and if that is true, ACS movement actions, scope resolution operator, execute, jump action, in parentheses, pass in the actor reference we are calling this on, just avatar actor, and that should be all we need to pass for this one. Okay, now let's do the same thing for stop action, copy, we're in stop action, let's remove this, and paste this here. Okay, that should be all we need to do. Let's compile and test in the editor. So make sure you have the editor closed and make sure that your code is correct before compiling. Okay, mine compiled successfully. Before we test, we need to make sure our hero character inherits from our C++ class. Mine inherits from ACS hero character, which is the C++ character class that I'm using. If not, then we need to set our blueprint character to inherit from our C++ character. Go to class settings and find your C++ character here and select that as the parent class. That should be everything we need to do. Let's go ahead and test it out. And as you can see, print start jump for both, but okay, so in our C++ for stop jump, we forgot to change this to stop jump action. Let's try live coding and see if that works. Live coding can be a little hit or miss. Hopefully that was able to fix it for us. Okay, and that works. We have start jump and stop jump. Okay, now what we can do is we can actually implement this in the blueprint. So event start jump action and event stop jump action. So if we implement this into the blueprint, since this is a blueprint native event, so I can go ahead and print string blueprint start jump action and blueprint stop jump action. Let's go ahead and try again. And you can see it prints to the screen. And in the output log, we no longer see the C++ version being called. And that is because the C++ version is not being called anymore. If we want to call the C++ version, we'll have to call super on these functions, similar to how we did earlier in the C++. In Blueprint, you simply need to right-click, add call to parent. So this is equivalent to calling super. We do that for both of these. We should get both in the output log. And as you can see, we get both, exactly as we are supposed to. We can call the C++ implementation in addition to the Blueprint implementation, or we can completely override them if we don't call the parent version. So for example, we can add jump here, and we can add stop jumping here. Let's test. Nothing gets printed or shown in the output log, but jump now works. You can leave these in the blueprint if you want to, but I'm going to implement these in the C++. Back here in the C++, let's go to the hero character. Let's remove these UE logs. And for start jumping, let's call jump. And for stop jump action, stop jumping. Okay, let's go ahead and fire off live coding and see if it works. If not, we'll have to close the editor and compile manually. Okay, that's working. Modifying our jump action to use an interface instead of a cast actually made a positive change to our code by reducing coupling. If you don't know what coupling is, coupling measures how much one class or module depends on another. Low coupling means classes are independent and flexible. High coupling means they are tightly interconnected and hard to change. Previously, our jump action required the avatar actor to be a character so that we can cast to the character class and call the character jump functions. But now we are using the movement actions interface for that. So this character include is not needed anymore. Our jump action is now more flexible because it is no longer coupled with the character class. We can now, for example, use the jump action with a pawn if we wanted to. This video has become quite long, so I think this is a good place to end it. In this video, we learned about inheritance and polymorphism and how we can use those concepts to treat different action types uniformly while preserving their unique behaviors. We also made use of interfaces, which allowed us to improve the flexibility and reduce coupling. Thanks for watching, and I'll see you in the next part.